Today, we're diving deep into two of the most important JavaScript engines in modern development, Hermes and V8. If you've ever worked with React Native, you've already used Hermes, even if you didn't know it. And if you've built anything for the browser or Node.js, you've absolutely used V8. But have you ever wondered what actually happens to your JavaScript code inside these engines? How do they differ in their approach? Why does one start up faster on mobile while the other dominates server workloads? That's exactly what we are going to unpack today. We'll cover the core architectural differences, the memory and garbage collection strategies, real performance numbers, and by the end, you'll know exactly which engine is doing what and why it matters for your code. This is particularly timely because just a few months ago, in February 2026, React Native 0.84 shipped Hermes V1 as the default engine, a complete rewrite with a new compiler, new bytecode format, and improved JIT. So this comparison has never been more relevant. Let's get into it. JavaScript engines are the invisible foundation beneath every web app, mobile app, and server. For most developers, they're an afterthought. You write JS, the engine handles it. But when you start caring about performance, especially on mobile, the engine choice becomes critical. Here's the reality. Hermes version 1, which just shipped as the default in React Native, delivers about 40% faster cold start times compared to 2024 builds. That's not a small number. On a mid-range Android device, we're talking about going from 1.3 seconds down to under 800 milliseconds. Users feel that difference. On the other side, V8 powers literally billions of devices, every Chrome browser, every Node.js server, every Deno runtime. It's one of the most sophisticated pieces of software ever written. Understanding how these two engines differ in their approach to compilation, memory, and execution is what separates developers who tune performance from developers who just hope things are fast. Let's meet these two engines properly. Let's properly introduce our two contenders. On the left, Hermes. Built by Meta, formerly Facebook, Hermes was created with a very specific goal: make React Native apps start faster on Android. The insight was that mobile devices, especially mid-range Android phones, are RAM constrained and CPU limited compared to a laptop or server. So Hermes makes a fundamental trade-off. It compiles your JavaScript to bytecode ahead of time, at build time, rather than doing all that work when the user opens your app. The engine ships with your app bundle, and when the user taps the icon, the heavy lifting is already done. Hermes version 1, which just became the default in React Native 0.84, is a complete rewrite. New compiler architecture, new bytecode format, improved JIT for hot code paths, and a new concurrent garbage collector called Hades. On the right, V8. Built by Google, V8 is the engine that powers Chrome, Node.js, Deno, and Microsoft Edge. It was built for a completely different world, long-running sessions in browsers and servers where you can afford to spend time profiling and optimizing at runtime. V8's JIT compiler, called TurboFan, watches your code as it runs, identifies the hot paths, and compiles those to highly optimized machine code. Given enough time, V8's peak performance can exceed Hermes. But given enough time is the key phrase. On mobile cold starts, that time doesn't exist. Two different philosophies built for two different worlds. Let's go deeper. Let's look at V8's pipeline. I'm giving you just enough to understand the contrast with Hermes. We could do an entire video on V8 alone. When V8 receives your JavaScript, it first runs it through a parser that builds an abstract syntax tree, basically a structured representation of your code. Then it hands that AST to Ignition, which is V8's interpreter. Ignition converts the AST into bytecode and starts executing it almost immediately. This gives you a fast initial startup, but the code is running in interpreted mode, which is not peak performance. Here's where V8 gets clever. While Ignition runs your code, it's also profiling it. It watches which functions get called repeatedly, the hot paths. These hot functions get handed off to TurboFan, V8's optimizing JIT compiler. TurboFan analyzes the runtime types, makes assumptions about what types those variables will always be, and generates highly optimized machine code for those specific patterns. The result is that V8's performance profile looks like a curve, starts okay, gets better over time, and eventually achieves near native speed for frequently executed code. This is perfect for a browser where a user might spend 30 minutes on a page, or a Node.js server handling thousands of requests. The JIT has time to warm up and optimize. But notice the trade-off. That optimization work happens at runtime, consuming CPU and memory on the user's device. On a mobile phone with limited resources, this is expensive. That's exactly the problem Hermes was designed to solve. Now let's look at Hermes, and you'll immediately see the fundamental philosophical difference. Hermes splits its work into two completely separate phases: build time and runtime. At build time, meaning on your developer machine or your CI server, the Hermes compiler takes your JavaScript source code, parses it, runs optimizations, and compiles it all the way down to Hermes bytecode, stored in a .hbc file. This bytecode is compact, binary, and designed to be loaded extremely efficiently. It gets bundled directly into your app. At runtime, on the user's device, none of that compilation work needs to happen. The Hermes VM just loads the pre-built bytecode directly and starts executing. There's no parsing, no AST construction, no JIT warm-up cycle. The app just starts. Hermes version 1 adds a really important layer here: a JIT compiler for hot code paths. So for code that runs repeatedly, like your render functions or event handlers, Hermes will JIT compile those at runtime for peak performance. But critically, startup doesn't depend on JIT at all. You get fast starts and good sustained performance. The Hades garbage collector, which we'll cover in more detail shortly, runs concurrently, meaning GC pauses that used to cause dropped frames in list scrolling are largely eliminated in Hermes version 1. The trade-off: your app bundle is slightly larger because it contains pre-compiled bytecode instead of raw JavaScript, but the startup and memory wins far outweigh that cost on mobile. This is the heart of the whole comparison: AOT versus JIT. Once you understand this trade-off, everything else falls into place. Ahead of time compilation, what Hermes does, means that all the work of converting your JavaScript into something the machine can run happens before the user ever touches your app. Your CI pipeline runs the Hermes compiler, it produces compact bytecode, and that bytecode ships in your app bundle. When the user opens the app, the engine can start executing immediately with no warm-up penalty. Just-in-time compilation, what V8 does, means the compilation happens while the user is running your code. V8 starts interpreting right away through Ignition, then uses profiling data to identify what's hot, and hands those parts to TurboFan for aggressive optimization. The generated machine code can be extremely optimized, often better than anything AOT could produce, because it has actual runtime type information to work with. So who wins? Neither wins unconditionally. It depends entirely on the execution context. If you're writing a React Native mobile app that needs to cold start in under a second on a budget Android phone, Hermes wins, not even close. If you're writing a Node.js API server that runs continuously for days, processing millions of requests, V8 wins because TurboFan has all the time in the world to optimize your hot paths. Hermes version 1 softens this trade-off by adding a JIT compiler for sustained performance, but startup is still AOT first. It's the best of both worlds for mobile. Garbage collection is one of those things that most developers never think about until their app stutters. Let's look at how Hermes and V8 handle memory differently. Both engines use generational garbage collection, the core idea being that most objects die young. Short-lived objects like temporary variables and intermediate render values are allocated in a young generation space and collected frequently with fast, cheap passes. Objects that survive multiple collections get promoted to the old generation and collected less often but more expensively. Hermes version 1's garbage collector is called Hades, and it's designed specifically around the constraints of mobile devices. Hades runs its marking phase concurrently, meaning it does most of the GC work on a background thread while your JavaScript is still executing. This dramatically reduces GC pause times. Those freezes you used to see when scrolling long flat lists are essentially gone in Hermes version 1. On top of that, Hades keeps memory usage 15 to 20% lower than V8 on equivalent workloads, which is a massive win on devices with 3 or 4 gigabytes of RAM. V8's garbage collector is called Orinoco, and it's a highly sophisticated beast. It has separate spaces for new objects, old objects, large objects, and even compiled code. It uses parallel scavenging for the new space and incremental marking for the old space. It's incredibly capable, but it's tuned for long-running sessions where a bit more baseline memory usage is acceptable in exchange for maximum throughput. For a React Native app, Hades is the clear winner for everyday use. For a server process handling huge JavaScript objects over hours, Orinoco's design wins. Let's talk numbers, because benchmarks are where opinions end and data begins. The 40% faster cold start is the headline number from Hermes version 1. React Native's own blog confirmed this when they shipped version 0.84 in February 2026. On mid-range Android devices, this translates to cold start times under 800 milliseconds. That's the difference between an app that feels instant and one that feels like it's struggling to wake up. The 20% lower memory usage is consistent across real-world migrations. Teams that upgraded to Hermes version 1 reported memory reductions in the 15 to 25% range on equivalent workloads. For users with 3 or 4 gigabytes of RAM who are also running 15 other apps in the background, this matters enormously. The 40 times reduction in JS to native call latency isn't specific to the engine comparison. It's the result of replacing the old bridge with JSY, the JavaScript interface. But Hermes is tightly integrated with JSY, and together they make native module calls dramatically faster than the old async bridge ever could. This is why animations in React Native now feel native rather than laggy. Now, to be fair to V8, in sustained server workloads, V8's TurboFan JIT will eventually produce better peak throughput than Hermes for pure computation. V8's mature ecosystem and decades of optimization work show up in server benchmark suites. But on mobile, for the metrics that users actually feel, Hermes version 1 is the clear choice. Let's talk about bundle size and startup time separately because they're related but distinct wins. Looking at the cold start bar chart, Legacy Hermes from 2024 was already a significant improvement over JavaScript core, getting apps started in around 1.3 seconds on a mid-range Android. Hermes version 1 cuts that nearly in half, under 800 milliseconds. Users categorically cannot tell the difference between 400 milliseconds and 800 milliseconds on app launch, but they absolutely notice 1.3 seconds versus 800 milliseconds. That's the threshold where it starts feeling like a real app versus a slow one. I've listed V8 here for reference with a caveat. It's not a direct comparison because V8 on a browser or node context doesn't face the same cold start constraints. A browser tab is never truly cold starting a V8 instance the same way a native app does. On bundle size, this is a secondary win but still meaningful. A typical React Native JS bundle might be 2.5 megabytes of raw JavaScript. Hermes bytecode for the same codebase comes in around 1.8 megabytes. That's roughly 28% smaller. For developers targeting markets where app download size matters, like Southeast Asia, India, or Latin America, this is genuinely impactful. But the key takeaway in the green box is worth reading carefully. The bundle size saving is not the main win. The main win is eliminating JavaScript parsing on the user's device entirely. Parsing is CPU intensive and blocking. By shipping pre-compiled bytecode, Hermes removes that cost completely from the user's experience. Everything else is gravy. This slide is why this video is timely. Hermes version 1 isn't just an incremental update. It's a substantial rewrite that changes the performance profile of every React Native app. Let me walk you through the timeline. Hermes became the default engine way back with React Native 0.70 in 2022, replacing JavaScript core on both Android and iOS. That was a big win, but the engine was largely the same architecture until 2025. In React Native 0.82 last October, Hermes version 1 was made available as an experimental opt-in. The community started testing it, filing bugs, the meta team iterated. And then in February 2026, React Native 0.84 shipped it as the default, no configuration required. So what actually changed in version 1? The compiler is a ground-up rewrite, better optimization passes, and critically, native ES 2024 support. You can now use modern JavaScript features like array.group by promise. With resolvers and more without Babel transforming them down to ES5. The engine handles them natively, which means less runtime overhead and smaller bundles. The JIT compiler is new. Legacy Hermes was almost purely AOT with a very limited JIT. Version 1 has a proper JIT for hot code paths, so you get AOT fast starts and good sustained performance for compute-heavy workloads. Hades is the new concurrent GC. This alone fixes a whole class of performance issues that React Native developers have complained about for years. And the bytecode format itself is new and incompatible with legacy Hermes, which is why React Native version locks its Hermes binaries. You can't mix versions. Let's make this practical. When should you actually care about which engine you're using? For Hermes. If you're building a React Native app, you're already using Hermes. It's been the default since version 0.70, and there's essentially no reason to switch it off. The wins on mobile are unambiguous. Cold start, memory, GC pauses. Hermes wins across the board for the mobile use case. If you're targeting markets like India, Southeast Asia, or Latin America where mid-range Android dominates, Hermes version 1 is especially important. The difference between 800 milliseconds and 1.3 seconds cold start is the difference between a good user experience and a bad one on a budget device. For V8, you don't really choose V8 for browsers. It's what Chrome and every Chromium-based browser uses, period. But for Node.js and server workloads, V8 is the right answer. Long-running processes get to benefit from TurboFan's JIT optimization over time. If you're processing large datasets, running ML inference in JavaScript, or handling thousands of requests per second, V8's mature JIT and large ecosystem of optimizations give you the best peak throughput. The honest answer for most developers is you don't choose. The platform chooses for you. React Native gives you Hermes. The browser gives you V8. Node.js gives you V8. What you can do is understand the implications of each, write code that plays to the engine's strengths, and use this knowledge when debugging performance issues. Now, is there any case where you'd want to disable Hermes in a React Native app? Yes, if you're using a native module that hasn't been updated to work with the new architecture yet. But that list gets shorter every month. And that's a wrap on Hermes versus V8. Let me leave you with 3 takeaways that you can apply immediately. Number 1, these are fundamentally different philosophies, not just different implementations. Hermes made a deliberate choice to prioritize startup and mobile constraints by doing compilation work ahead of time. V8 made a deliberate choice to maximize peak performance for long-running sessions through JIT. Neither philosophy is wrong. They're optimized for different worlds. Number 2, Hermes version 1 has genuinely closed the gap. The old criticism of Hermes was that it was fast to start but slow to run. Hermes version 1's JIT compiler and Hades GC address both of those concerns. For most React Native workloads, Hermes version 1 is competitive with V8 for sustained performance while being dramatically better at startup. This is a huge deal for the React Native ecosystem. Number 3, in practice, you don't usually choose. Your platform chooses for you. But understanding how the engines work lets you write better code, avoiding patterns that confuse the JIT. Understanding why your app might be stuttering during GC, knowing which startup bottlenecks are engine level versus app level. If you found this useful, there's a lot more coming. I'm planning deep dives into V8's TurboFan JIT in detail, how JSI replaces the old bridge, and the React Native new architecture end to end. Hit subscribe, follow me on Twitter or X, and I'll see you in the next one. Go ship fast apps.